Question number 11. A vessel contains oil, density 800, and mercury, density 13,600. A metal sphere floats at the interface with one half of its volume immersed in mercury and the other half in oil. The density of the metal is. I will draw a diagram. We know that density of mercury is greater than the density of given oil. Density of mercury 13,600. Density of oil 800. There are two forces on this object, weight and upthrust, but upthrust is separately given by oil and mercury. Then we can write upthrust U1 plus U2 equals to weight of the object. We can write U1 immersed volume V over 2 in mercury, half of total volume. Density of liquid 13,600 when considering mercury, G plus immersed volume in this oil V over 2. We have to consider only this part of volume. Density 800 G. Weight of the object. When writing mass, we can write it density of object into volume. Density into volume. Now we have to consider total volume. When calculating upthrust, we have to consider immersed volume. But this is mass. Then we have to substitute total volume into G. Now we can cancel out G. V. We have to divide by 2. 13 divided by 2, 6. 1 remaining. 16 divided by 2, 8. 0, 0. Plus 400 equals density. 6,800 plus 400. 7,200 kilogram per cubic meter. It is the density. Then answer is 4 for the question number 11. Then 12. A crown of mass 1.4 kilograms has an apparent weight 1.3 when submerged fully in water. The mean density of the material of crown is. Apparent mass means if the crown is hanged by a spring balance. The reading of a spring balance when crown is submerged in water is the apparent mass. Then it means tension of this coast. We can consider equilibrium of crown, tension plus upthrust equals downward force weight. Now they have given tension. It is the apparent mass 1.3 kilograms. 13 Newton. Upthrust 0 G. Now we can substitute volume of crown, density of water 1000. When considering upthrust, we have to substitute density of liquid G10 equals mass of crown is given as 1.4 kilograms. It means 14 Newton. Now we have to find the density of material of crown. I will subject V term 14 minus 13 1. Now we can substitute volume. Volume of crown. We know that density equals mass divided by volume. Volume is mass divided by density. Then mass 1.4 kilograms divided by density. Now we can subject density. 1.4 into 10 to the power 4 in SI unit, kilogram per cubic meter. Answer is 4 for the question number 12. If this density is equal to density of gold, it is made by gold. It is the Archimedes method. If the density is not equal to density of gold, the crown is made by the mixed alloy. Then 13. A tube of length L is fitted. A tube of length L is fitted to a vessel having length L and the bottom area A, as shown in the figure. If the internal area of cross-section of the tube is A and the vessel and tube is completely filled with the liquid density rho, the force acting on the bottom of the vessel by liquid D. We know that when considering this container, pressure at this point is H rho G. Total height is, this height is given as L, this height is simple L. Then total height L plus simple L. Density of the liquid rho G is pressure at the bottom. We have to find the force acting on the bottom. Then we know that pressure equals force divided by area. This area is given as capital A. Then we can substitute pressure L plus L rho G, force over area. Now we can subject force area into L plus simple L rho G. Capital A into L plus simple L rho G. Then answer is 1 for the question number 13. They have not considered the atmospheric pressure. It means the problem should be the resultant force acting on the bottom. If we are considering resultant force, we can consider there is the atmospheric pressure on the bottom in upward direction should be equal to downward direction. But they have given all answers without considering atmospheric pressure, then we can get answer is 1. Pressure is not depending on this area. Then 14. A cylindrical metallic vessel having a thin wall, walls of height 4h, contains water up to a height h. When immersed in water, this cylinder floats with half of its height below the water surface, as shown. If the cylinder is to be floated with its almost entire height underwater, the water level inside the cylinder has to be raised from H. Now I will draw the given diagram. Half of vessel is immersed in water. The water level inside the vessel is H. Then this height also H. When considering the equilibrium, we have to consider the resultant volume of the resultant immersed volume of the vessel. And we can get resultant immersed volume is this volume because of this black colored volume, because of there is no an upthrust on water due to water. Then resultant upthrust is acting only on this part. Then when the vessel is fully immersed, it means outer water level should be this level. The water level difference of water level outside and inside should be this H height, black colored volume is constant. This side. It is the required, it is the volume which can give required upthrust. Then this height should be h and this water height should be 3h. Water height inside the vessel should be 3h. Then we have to find the water level inside the cylinder. Has to be raised from h to 3h. New height should be 3h. Water height inside the vessel. Then answer is 4. Then 15. A beaker of water is kept on a compression balance at time t equals 0. A solid object immersed just beneath the water level as shown in the figure. We know that when immersing an object in water, there is an upthrust on the object. And according to Newton's third law, there is an equal and opposite downthrust on this system, water vessel. This reading is the increasement of reading of balance. Then we can get initial reading is like this. They have given object immersed just beneath the water. Then final reading of the balance should be a greater value. Then answer should be 1 for the 15th question. Then question number 16. A uniform solid cylinder of weight 6 Newton is floating vertically in a liquid with 1/4 of its height above the liquid surface. Solid cylinder. 1/4 of height above the liquid surface. The minimum vertical force required to immerse the cylinder fully in the liquid is. Now we can consider equilibrium. Upthrust equals weight. Upthrust V rho G. Weight. V is the immersed volume. We know that immersed part is 3/4 of its volume. 3/4 of volume. Density of liquid, we can cancel out G. Mass of object. When considering fully immersed situation, the immersed volume is V, total volume. Density of liquid is same. We have to get the force mass plus given force, but we have considered, we have cancelled out G value. Therefore, we have to use force divided by G. Then we can find the F by using these two equations. We can substitute M value for this one. Oh, there is another method. I think that it is easy to simplify. I will use that method. It means the given force should be equal to upthrust on this part, non-immersed part. Then we can get given force equals to upthrust of non-immersed part. Volume 1/4H, 1/4V. I will consider total volume as V. Rho G. It is the first equation. Now we can get total weight of the object, mg, should be equal to 3/4 abstract from this part. It means 3/4 of volume rho g. Now weight is given as 6 Newton. We can use 6 Newton. 6 equals 3/4 V rho g, second equation. And we can divide two equations. F divided by 6 equals 4 is cancelling, 0 g terms cancelling, 1/3. Then F equals 6 divided by 3, 2 Newton. Then answer is 2 for the question number 16. Then 17. When a bottle of soda water is opened, gas bubbles rise in soda water. Assume that the initial acceleration of the gas bubble is a. When the bottle falls freely, then with respect to the bottle, the gas bubbles, we have to consider the motion of gas bubbles relative to water. We know that upthrust is 0 g. Upthrust is 0 g. And for a free falling object, we can observe weightlessness. It means we can consider for a free falling object there is no resultant gravitational acceleration relative to the system, not Earth. Therefore, the gravitational acceleration on the bubble relative to bottle is 0. Therefore, we can get upthrust is 0. It means bubble will not move in upward or downward direction. Then answer should be 4. The bubbles will remain stationary. Question number 18. A uniform solid cylinder of cross-sectional area A and mass m floats in a vessel of water, density D, as shown in the figure. When the vessel is raised upward with a constant acceleration A, the height of the cylinder submerged in water will. Now we can use same method. I will explain how the acceleration, gravitational acceleration resultant gravitational acceleration is changing by using this object. I will consider a mass on a balance, weight mg, reaction R. This reaction is equal to the reading of the balance because of the force exerted on the balance is equal to R reaction. Then this is the reading. Now I will consider the reading when moving with A acceleration in upward direction. The system is moving upward direction with simple A acceleration. Then we can use Sp equals ma for the object. F is R minus mg. Resultant force on the object should be R minus mg. R should be greater than mg because of the object is accelerating in upward direction. Equals ma. R equals m times a plus d. Now you can identify the reading of the balance when the system is at rest should be mg. Now m into a plus d. Then resultant acceleration is a plus d because of it is accelerating in upward direction. If the system is accelerating in downward direction, this reading should be A minus G. We can write it G minus A. G minus A. Now, in 17th question, they have given that falling acceleration is equal to gravitational acceleration, free falling. Then G minus G, the apparent weight of object should be 0. R dash should be 0. G minus G 0. Now, for this situation, we have to consider that acceleration, resultant acceleration A plus G. Now, we have to find the height of cylinder submerged in water. For the first situation, immersed height h1. When accelerating system in upward direction, the immersed height should be like this, h2. Now, for the first situation, V rho G equals mg, plus V equals weight. G is cancelling. For the second situation, new immersed volume V dash rho G equals mg constant. For the acceleration for the second part, G plus A. Now we can cancel out acceleration. It means the immersed height should be equal to both situations. We can equal this part and this part. Then V dash equals V. Then answer should be 5 for the question. Number 18 remain unchanged. Then 19. A U-tube contains a liquid as shown in the figure. When the tube is moved horizontally to the right, 19. The rocket carries 1.8 into 10 to the power 4 kilogram of liquid oxygen in a vertical tank of cross-sectional area 3 square meters. At the lift off, the rocket accelerates vertically upward at 2 meters per square second relative to the earth. The pressure on the bottom of the tank at the lift off is. Now I will draw the oxygen tank. Vertical acceleration 2 meters per square second. Oxygen mass is given as 1.8 into 10 to the power 4 kilograms and 10 to the power 5 newton. Now, there is a reaction on oxygen volume due to the bottom surface of cylinder. We have to consider the reaction on the bottom as the force exerted on the bottom due to oxygen. Then we can consider F equals ma. We are using 2 oxygen. Force, resultant force R minus 1.8 into 10 to the power 5. Mass 1.8 into 10 to the power 4. Acceleration 2. Then we can find the reaction. 1.8 into 2, 3.6 into 10 to the power 5 plus 1.8 into 10 to the power 4 plus 5. Now they have given the area. We have to find the pressure. Then we can add, we can get it as 0.36 into 10 to the power. So I will change this one. 3.6 into 10 to the power 4 plus 18 into 10 to the power 4. 21.6 into 10 to the power 4. It is the force on the bottom. And then we know that pressure equals force divided by area. Force equals pressure into area. Now we have to find the pressure. Then we can substitute directly. Force 21.6 into 10 to the power 4 divided by area is 3 square meters. 21 divided by 3, 7.2 into 10 to the power 4 Pascal or Newton per square meter. Then answer is 5 for the question number 19. Then 20. A U-tube contains a liquid as shown in the figure. When the tube is moved horizontally to the right with a constant acceleration A, the difference in the height of the liquid column in two limbs is. When considering the system, we can observe that this L length of liquid is reacting to the acceleration. It means when accelerating the system, this horizontal length, this vertical column could not move. Therefore, this horizontal length is trying to move in backward direction. It means we can consider the accelerating situation. When accelerating the system, this height should be less than this one. Height of this column should be greater than this one. There is a height difference. We have to find the height difference. Now, there is a pressure difference. We can consider pressure difference H rho G. Therefore, resultant force, we know that pressure equals force divided by area. Force equals pressure into area, delta P into area. Pressure difference H rho G into area. Now we can use F equals ma to this part, this horizontal length. Only horizontal length is moving when accelerating the system. Then we can use F equals ma to the horizontal part, this part. Force is H rho Ga. Mass of this part. Mass is volume, density is mass divided by volume, mass is density into volume. Then density into volume. Volume is cross-sectional area into this length. We have to use only this part. Mass into acceleration A. Now we can find H value. We can cancel out rho A. Then H is LA divided by G. Answer is 1 for the question number 20.